Alrighty, February 4th, 2019. Hi, Carlton from the Pharmacy Seeds Network. I tried to record this late last week sometime, but I got done recording the whole thing and realized the audio track was all messed up. So, re-recording it now. I have better data, and hopefully this take will be better anyway. So we're going to go over what thermal mass, the effect that thermal mass can have on mediating temperatures. So what we're looking at right here is a program called SQL Dashboards, and it's a free download on the internet. I'll put the link in the description. And it's a Windows-based program. Unfortunately, they don't have a Linux version, but well, I won't get into all that. Anyway, so I use SQL Dashboards to create charts from the data that I'm capturing on the Raspberry Pi in the greenhouse through the database. So I basically take the data from the database and project that onto a chart. And I use simple SQL statements like this. So in this particular case, we're looking at the date time. That gives us this lower scale here. And then stove temperature, which is the red. Outside temperature, which is the blue. The hot 3 and hot 4, that's the big thermal mass on top of the stove in the greenhouse. Tmass temp and Tmass temp, average of those two, of course. Tmass temp and Tmass temp low is that large thermal mass, the IBC tote, 275 gallons. Obviously, we're looking at the average of that as well. So let's see, the green is hot 3 and hot 4, and the red is the IBC tote. All right, and so I capture a data snapshot of all the temperatures on all the sensors in the greenhouse every minute of every day. So if I go back and I look at the last 1,440 records, I can see the last 24 hours of greenhouse performance. And so what we're looking at right now is live, and I'll scale this up a bit. And just so you can differentiate, we're using two different charts here. Actually, let me unscale this quick so you can see the statement here. The one chart is BTUs in storage. That's calculated based on the temperature difference between 60 degrees and the temperature that the two thermal mass tanks are at. Each thermal mass tank is calculated independently so that we don't have an averaging effect misrepresenting. They're different volumes. That's the reason for that. So anyway, upper chart here is BTUs in storage, lower chart is actual just temperatures. So actually what we'll do here is we'll go back and look at the last 5 days, or 7,200 records. And we'll do that on both of these. Whoops. And then we'll full screen this up so you can see it a little easier. I'm going to compress the BTUs a bit. And it takes a second to retrieve all those records. There's about 30 sensors in the greenhouse, so there's about 30 different data fields for each record set. So it's actually a tremendous amount of data. So anyway, it takes a minute to update it. But as you can see, it's updated. And so now what we're looking at is the last 5 days of temperatures from the current time, which is 10:41 p.m. Eastern Time on February 4th, 2019. So looking back over that, going from right to left, most current is to the right, oldest is to the left. You can see the outside temperatures here were well below zero for a few nights in a row at least, and actually it goes back further than that, but we don't need to look that far back to understand how the thermal mass helped. So you can see that I'm usually starting up the stove by 4:30 in there, and you can see the stove temperature climb rapidly, and you can see each stoke cycle as it goes through. Those jagged marks are a new stoke cycle where the wood is caught fire and is burning at maximum temperature, and then you can see it tail off, and then you can see me add wood again. The green line here, like I said, is that thermal mass on top of the stove in the greenhouse. That's that primary one with the coil in it, and that pumps heat secondarily across to the other one. So you can see as this one climbs up, you can see the temperature, or the difference, the program that detects the difference between that thermal mass and the other one. You can see that come on and off and trip the pump on and off accordingly and transfer heat out from that thermal mass to the big one. and you can see the thermal mass, the big one here, reflecting that heat transfer as it climbs. And so at 3:46 a.m. on the 31st of January, or 4:01 a.m. on the 31st of January, we were at 111, an average of 111 degrees in that big 275-gallon tote. And then you can see I put in one last stoke. I throttled the stove back so it would carry out a little bit longer. You can see at that point in time the outside temperature was about -8, so it's pretty cold out. And oh, this is the average greenhouse temperature here. I should mention that. So you can see that run accordingly as well. And then you can see when I drop the stoke off how fast the temperature drops. But you can see also that it doesn't go below a certain level, even though there's a tremendous difference in heat production from the stove. And that's because we've gassed the thermal mass up. And if we look up here at BTUs, you can see that each of these tanks takes on a pretty good amount of heat. So the thermal mass on top of the stove is the green line here. That's BTU store. And then the BTU stored 2 is the tank that sits on top of the big tote. That's that reserve water tank. I have sensors in there anyway just to kind of monitor. You can see that really never goes much over 10,000, but it does have some heat, 10,000 BTUs, but it does have some heat storage. And then the big bank is the blue line here, and that's the IBC tote, the 275-gallon tote. So you can see we had about 160,000 BTUs by the end of that last stoke cycle, and it never really went much up over well, throughout the day it never really went much up over 15, 17 and I would say it was probably a little less than that. That sensor this time of year gets a little bit of sunshine on it, so it was probably closer to 12 or 14 degrees. And you can see as the stove is no longer producing as much heat, you can see the thermal masses dropping that heat back off into the greenhouse and helping to stabilize the temperature. And of course you can see a little bit of like where the sun came out here, and that's the other thing, you can actually see when the sunny days are, because there's a lot more thermal gain on sunny days. Like here and here were days where we had some sun, and like here was pretty much a cloudy day, couple sunspots. Whoops, I'm backwards here. Sorry, I'm looking at, this is nighttime, this is daytime between stokes. I got a little mixed up. Anyway, so you can see what's going on here. Anyway, the whole point of this video is that using thermal mass, you can help mitigate the temperature in a greenhouse or any structure, and water is a great way to do that. Water has a specific heat of 1.00, and so that's very high. I think concrete is about 0.5, and I think rock is around 0.6, and I think yellow southern pine, for example, is around 0.7. So just kind of gives you a reference of how much heat water is able to store on a per cubic foot, cubic centimeter, whatever basis. Anyway, I just thought I would go over this and how it works, and people are always asking about greenhouse temperatures and the extreme cold, and I thought this would be a great way to show off how it works, and also give you a taste of Raspberry Pi and MySQL statements, and how to pull data back from a database and use it and actually create charts from it. I watch this chart all the time, and that's how I keep an eye on where I'm at stoke-wise in the greenhouse, and then I know when I have to stoke next. There's no guesswork about it. So I guess that's it. We'll go back to the 24-hour period here quick and just let you have a look at that. Any minute now. I'm running about a 280-foot line out to the greenhouse for cabled Ethernet, so it's not quite as fast as if it was right next door. Anyway, so you can see today we had a good bit of sun. I was able to let off stoking relatively early last night. That was nice. I got a little bit more rest, which I needed from long nights of stoking. And you can see where the sun came out today, and how much that warmed the greenhouse. It was actually up over 100 degrees in there today, 104. So that's nice to see. And then there's one spot where these very tall pine trees here actually shade the greenhouse before it gets sun again. You can actually see that dip there as well. And with the stove throttled back, you can also see that reflected in the stove. There are some coals in the stove during the day, but not much heat production, so it kind of fluctuates along with the sun. Anyway, finally we're back up into some relatively warm temperatures. Yeah, obviously that 80 wasn't quite right. We had about 60 out today. And tonight we're down to 45. Things are thawing. I've got the ram pump back online and pumping. Well, pumping but not delivering yet, because I'm still waiting for the delivery line to thaw out. But I expect that to happen in the next 12 to 24 hours, and I can refill tanks in the greenhouse, give all the plants a much needed watering, and carry on. Anyway, I hope you found this interesting or informative. If you have questions, don't hesitate to ask. I always answer in the comments. Thanks for watching the Pharmacy Seeds Network, and yeah, that's that. Oh, yeah, don't forget to like and subscribe if you like the video or you want to subscribe to the channel. Thanks for watching.